Hi. So today we'll start a new series, which is the microeconomic theory, and we'll use the very classical textbook, which is written by three people. So in short, it's called MWG. Okay, and it's a very nice textbook for us to study the microeconomic theory. So okay, so now let's write that down. Okay, so microeconomic theory, and so the textbook is called MWG, and it was about, it should be written in 90s, I think, right? So it was a long time ago, but that is still a very nice textbook, and we'll try to cover as many chapters as we can. Okay, so economic, or especially microeconomic theory, it essentially talks about the how do people make decisions under some constraints, right? And how do we efficiently allocate some resources? Okay, so those are the very common topics that we might often see in economics, or especially microeconomics. Okay, so and if you can go over the table of contents in the textbook, and you can see that this textbook basically it follows a very normal structure that is introduced the consumer theory first, which is called in the textbook is called individual decision making. Okay, and we have the so we first need to before so we want to study the decision making, so we need to know that what will be preferred by each individual, right? So how do we measure this preference, or how do we calculate the sort of the utilities or the rewards or the payoff that all the individuals they can obtain? So we need to define those things based on the preference or the choices, right? So so that'll be the first chapter that we're going to cover today. And later we'll also see that beyond the preference and choice, we will define how to measure the utilities of the individuals, and then we will study the consumer's theory based on that. Okay, and later we'll also study the in textbook and see that we have some chapters such as aggregate demand, and also later we'll go into the production, which is on the product producing side, right? So and we'll also cover the choice under uncertainty and some game theory, as if they have something that we didn't mention in our game theory series, right? Okay, so and later in part 3 in the textbook we will have this general equilibrium, right? It's called market equilibrium and market failure, and they'll discuss the competitive markets and the welfares and externalities and some IO problems, right? Industrial organization problems, and of course some adverse selection, signaling, screening, and principal agent problem. Okay. All right, so those would be essentially okay. And in part 5, they also have this very not new, but it's relatively new topics in social choice theory and mechanism design. Okay, good. So this will be a brief introduction to this textbook and in this course, microeconomic theory. So that we're going to try to discuss and study together. So, okay, good. So now let's start this topic in the individual decision making and consumer theory, right? Okay. So this will be part 1. Okay. Individual decision making. Okay. And this individual decision making is sort of, this is very common topic in the microeconomic theory studies, right? So many people, many researchers, they study this kind of problem and try to figure out how does individuals, or how does agents, how do the agents, they try to make some decisions under some certain constraints that they have, right? So different constraints or different problems make different kinds of research in this topic, right? Okay, so and there are basically two kinds of approaches to this individual decision problem. Okay. So some decision maker needs to make some choice, right? So this decision maker could have some preference. So this will be called preference-based approach. Okay. And sometimes we could also have another approach called choice-based approach. Okay. So those would be two kind of approaches, and we'll establish the connections between those. So the first one will be called preference-based approach. Okay. And another one would be called choice-based approach. Okay. So that's a rough, brief introduction to the part 1. So now let's directly go into the chapter 1, which is called preference and choice itself. Okay. Good. So when we're talking about the choices or the preferences, right? So we need to have some set, right? Mathematically, we need to have some set to include or to contain all those kind of alternatives that are available for us to choose or to prefer, right? So we'll have this called the set of alternatives. Okay. Let's say a graduate student could go to law school, or go to business school, or become a singer or something else, right? As stated in this example and in the textbook. So those would be all just some alternatives that some individual or this agent could choose, right? So this would be called a set of possible alternatives. Okay, so that's the first definition, or the first concept that we're going to have. So a set of alternatives. Okay, and we normally use this capital X. And this X, it could, let's say, the student could go to law school, right? Or maybe like find a job, right? Or become a senior, etc. Okay, so those are all the elements that can be contained in this set X. That includes all those positive alternatives that some person or some agent could choose, right, in this problem. Okay, so based on this set X, then we could define either the preference or the choice, or later the utilities, right, to how to measure how this individual is making this choice, right? Okay, good. Okay, so that'll be the introduction, 1.A. Okay, so now let's go to 1.B. and that'll be the preference relations. Okay, preference relations. Okay, so now we're gonna make this definition on the preference relations. So this is in the first approach that we discussed. It's called preference-based approach. Okay, so later we'll talk about choice-based approach, but here this preference relation is defined for this approach. Okay, so so the objectives of the decision maker are all summarized in this preference relation. Okay, so this is denoted normally by this notation. Okay, so it looks like a greater or equal to sign, but it's a tilde in below. Okay, of this sign. So this mathematically, this is just a binary relation. Okay, on the set X. Binary relation defined on X. All the alternatives. Okay, and it allows the comparisons of pairs of alternatives in this X. Okay, so when we are saying that X this Y, so we can read this as X is at least as good as Y, or we could read it as X is weakly preferred to or weakly preferred than Y. Okay, so those are similar statements. Okay, all right, so and using this weak preference, this relation, then we can define two other things. Okay, and one is called strict preference, another one is indifference. So a strict preference relation, and that is written as this. So this would be similar to the greater sign, right? Those are just the analog of the other those signs. Okay. So the definition of this strict preference is such that if we have X is strictly preferred to Y, then if and only if X is weakly preferred to Y, but not the other way around. Okay, but Y is not weakly preferred to X. So then in this case, this means that X is strictly preferred to Y. Okay, and we also have this indifference relation. Okay, and that is written by this tilde notation. Okay, so when we're saying that X tilde Y, so this means that X is weakly preferred to Y, and at the same time Y is weakly preferred to X. So that they are indifferent. Okay, and this can be read as X is indifferent to Y. Okay, good. So those are the definitions. All right, and then we're gonna introduce some important properties that those preference relations satisfy. Okay, and those properties will use some definition to give the properties. Okay, so this would be the definition of 1.b.1. Okay, all those labels they match the labels on the textbook. Okay, so you can always refer to the textbook if you want to see more about those things. So we say that a preference relation, a weak preference relation, so this is rational. Okay, so this is rational if it has the following two properties. So the first one is completeness. Okay, completeness. Okay, so it means that for the elements x, little x, little y in big X, we have x weakly preferred to y, or y weakly preferred to x, or both. Okay, so we can always compare which one is better, or weakly better, right? Or they're equally, or they're indifferent. So they always have some sort of relation, and this is called completeness, right? It's sort of like we're comparing to real numbers, right? It's a analog to this. Okay. And number 2, the second property will be the transitivity. Okay. Transitivity. Okay, so let's have 3 elements in big X, X, Y, Z. So let's say if X is preferred to Y and Y is preferred to Z, then if we have X is preferred to Z, we can prefer to Z, then this is called transitivity. Okay, and this is a very straightforward definition. Good. So those are 2 important properties if the relation satisfies those 2 completeness and transitivity, those 2 properties, then we say that a preference relation is rational. Okay. Good. So that'll be the setup, right? That'll be the definitions. Good. So now we could move on and talk about the what if this preference relation is rational? Okay, then what results we could have. So that leads us to the proposition 1.b.1 on the textbook. So let's say if this weakly preferred, this preference relation is rational, as we defined above. Okay, so if that rational, then we have some results. Okay, so a proposition means that we can prove, right? But the definition is not something that we can prove. But definition is just given, right? Okay, so so the first one would be if that's rational, then a strict preference. It is both irreflexive. So irreflexive means that X cannot be strictly preferred than X itself. Okay, so this never holds. Okay. Strictly preferred is both irreflexive and transitive. So if X is strictly preferred to Y to Z, then X must be strictly preferred to Z. Okay, so that'll be the first result, and we'll prove this later. Okay, so the second is this indifference is reflexive. It's not irreflexive, it's reflexive. So it means X is indifferent to X for all X. And this is obvious, right? Okay, and transitive, if X indifferent to Y indifferent to Z, then X indifferent to Z. Okay, and something else, and symmetric. Okay, Symmetric means that if x is indifferent to y, then we can write y is indifferent to x. Okay, we can change the order. Good. So that'll be the second result. Okay, and we have a third one. So the third one is written on the textbook, but actually it's an intermediate result. We actually we do not need that, but for us to better understand those properties or those propositions, so we could write it out as we did in the textbook. Okay, so it doesn't hurt if we write this out explicitly. So if, let's say, if x is strictly preferred to y, y is weakly preferred to z, then x is strictly preferred to z. Okay. All right. Good. So now let's prove those results. Okay, and we start from the third one, from the last one. Okay. Good. Maybe let's change another color. Proof. Okay. Let's start from the third. Okay. If, let's say, if y is strictly preferred to z, then it must be that y is weakly preferred to z. Okay. So just ignore the third argument. Let's say here, let's suppose that if y is strictly preferred to z, then it must be, this will imply y is also weakly preferred to z, right? Because weakly preferred is simply strictly preferred or indifferent, right? So this must be true. Because that implies this, so the transitivity, okay, gives us that x is weakly preferred to z. Okay. And now we suppose that the other way around. Let's suppose if z is weakly preferred to x, okay, and because y is weakly preferred to z, right? So the transitivity gives that y will be weakly preferred to x, right? But we know that from the third argument that we already have y is strictly preferred to x is strictly preferred to y, right? But it contradicts the argument that x is strictly preferred to y. Okay. So x must be strictly preferred to z, right? So it has to be so this cannot be true, right? So this is true, but this cannot be true, so this has to be true, right? Okay, good. All right, so that'll be the first, that'll be the third result that we have proved, right? Okay. So now let's move on and go back to the first one. Okay. So in the first one, we'll try to prove the for the strict preference, right? And to show that the strict preference is irreflexive and transitive. Okay. All right. So first, by the completeness. Okay. So X has to be weakly preferred to itself for every X. Okay. So it means that there does not exist any X such that X is strictly preferred to itself. Right? Yes, there is no X such that it is strictly preferred to itself. Then this proves the irreflexive, right? So this doesn't hold for our time. Okay. And next, let's suppose that X is strictly preferred to Y, and Y is strictly preferred to Z. Okay. Then what we have is X is strictly preferred to Z and weakly preferred to Z. Okay, because the strict preference here implies the weak one, right? And this implies X strictly strictly preferred to Y, and so the whole thing here, right? So that gives us directly Y is strictly preferred to Z, because we have already proved that from the third result, right? And then this from here we can arrive here, so this completes the proof for the transitivity of the strong preference, right? Okay, so that'll be the first result. And how about the second one? For the second, okay, so the second we're gonna prove for the indifference relation, and that'll be reflexive and transitive and symmetric. Okay, so first, because X is weakly preferred to itself for every X, so X is indifferent to itself for every X. Okay, so this proves the reflexivity. Okay, and next, let's suppose if X is indifferent to Y, Y indifferent to Z, then let's say, then we know that because the indifference implies the weak preference both ways, right? So it means that X weakly preferred to Y, Y weakly preferred to Z, and Y weakly preferred to X, Z weakly preferred to Y. Okay. All right, then we can use the transitivity, okay, and using transitivity. Okay, so this will become X is weakly preferred to Z, and Z is weakly preferred to X. Okay, so X is indifferent to Z. Okay, and this is transitive. Okay, All right, so the last result is symmetric, right? Symmetry. So let's suppose x indifferent to y. So this implies x is weakly preferred to y and y weakly preferred to x, right? Okay, then we can use the and then we can simply exchange the order of those two. Okay, so we can just write in the other way around, and it still hold, right? Because this and we can simply change the order of the and. So y is weakly preferred to x and x is weakly preferred to y. This still holds, and this gives us the indifference between y and x. Okay, so we come from x indifferent to y, and we end up with y is indifferent to x. Then this is the proof for the symmetry, right? Symmetric. Okay, good. All right, so those are the proofs for the proposition 1.b.1. And although those are very long and long proofs, but these are very interesting and quite useful for us to have some knowledge or some observation on how do we need to prove for those kind of statements or the propositions, right, in the micro theory. Good. All right, so that'll be enough for the first video in this series, and later we'll introduce how do we define the utilities on top of those preferences. Okay.